Hello and welcome back to Human Resource Machine. At the start of the number
Hello.
36.
I'm here too.
Sorry. Hello.
Yes.
I was so prepared to tell about like the start of 36.
Start of 36.
Because when we jump in here, everyone has to ask themselves, hey, I know how an unplayed level looks like. You played everything. And that's...
Well, we already discussed it in our
the start of where we
in some
the
previous
one where
videos and then
the one where we play 36.
Yeah.
That's like it should be like 2 episodes back or something.
yeah.
Ah.
So we are at episode 39 this time, and since we already
Yeah,
played this
level 39, yeah, not necessarily the episode.
Okay, that's right. Since we've already played this level, we decided to just get right to the code, and me as a non-programmer, I've never programmed before, I'm trying to go through the code and if I have any questions or don't understand something, then I would just ask.
Yeah, I think I actually took the lead on the final level, so the final few levels back when we played them.
Remember.
Yeah,
but I think most probably yes, because these are just very hard for a non-programmer
non-programmer, yeah.
to
But
do.
you should not be, if you like the game in general, you should not be discouraged, because it kind of leads you into it. If you tackle one question after the other, you should be fine. Okay, let's try it. So each number in the inbox is an address of a tile on the floor. Send to the outbox the coordinates of that tile. Column first, row second. Yeah. For example, address 6 has the coordinates 2, 1. You may ask your boss for more examples. Yeah, that's about memory, because things in memory only are linear, right? So there's only address 1, 2, 3, 4, 5, 6, 7. And if you want to express something like a matrix, which has rows and columns, you have to find a way to map the 1, 2, 3, 4, 5, 6, 7 to like a 3, 3 matrix or something. And this is essentially what that is.
Okay. Well, I know what a matrix is, but I don't know how to put it into code. Well, let's see. So this is what you have done.
Well, we don't remember who did it. Maybe you did it.
I'm pretty sure it was not me. So in the first line there says copy from D, or is it 0?
I don't know.
It is a 0, I guess. Okay. So you take the digit 0 from the indices 0. From the index 0.
Yeah.
So what is that for? And then you copy to the count. Oh, you want to create the matrix 0, 0? Is that what you want to do?
I guess I'm just initializing before I start, because I later will use the count variable.
Yeah.
If I look into the code, the first usage is to bump the count. So it counts something. I don't know what it counts right now, but it does count something. So we have to start with a count of 0. So something starts with a count of 0.
Yeah. Okay. So it's just initializing.
Yeah. I wouldn't go farther than that with speculation. It'll show what counts. We subtracted 4, right?
Okay.
That's the next step.
Why do we subtract 4?
Though. I would guess it's a division thing. We want to divide by 4, but we don't have a division, so we subtract until we can no longer subtract.
And specifically the 4, because there are 4 tiles in each row, and 4 tiles in each column.
Yeah, so if you take the 7 and you divide it by 4, The result is 1 and something, right?
If I take the 7 here, the
Yeah.
tile number 7.
Yeah. Which is the address 7. And like if you think about memory, it would be the address 7.
Okay,
And if you divide by 4, you would
4.
get 1 and a little bit.
that's right.
And if you, and that's because it's because you decided that one row has the length of 4, or well, the game decided that for us. And if you divide, you get like in the row in which it has to be in. So everything from 0 to 3, if you divide it by 4, it's 0 and a little bit. So it's in row 0.
Wow.
From 4 to 7, it's 1 and a little bit. That's why it's 1.
Okay.
From 8 and 11, it's 2 and a little bit. And from 12 to, I want to say 14, but I'm not sure.
So it should be 14.
12, 13,
12,
14,
14,
15?
15.
15. Oh yeah, because 4 times 4 is 16. Yeah, I see.
Okay. 15 divided by 4 is
3 and a little bit.
yeah.
Yeah, and it's all also because it starts with address 0.
Okay.
And that's like, and the little bit is actually very interesting, because if you subtract the 4 from 7 once, you get 3. And you can see that it's also in column 3, which is not a coincidence.
Row 3, column 3.
Yeah, that will be true for 7. If you go, like if you look at the input 12 right now, it would be 12 divided by 4. That is exactly 3, right?
Yes.
So it's 3 times 4 plus whatever column it's in. And it's in column 0 because 3 times 4 is already 12, right? And that's plus 0. It's essentially the size of the row times times the row it's in plus the column, and that's the address. That's how you get to the address.
Okay. So if
And you can even, so there's one important thing, you have to know the maximum in advance. And
you mean a maximum of columns and
yeah,
rows?
the maximum of columns and rows, and that's for essentially the maximum of elements in the set. Because now if you say we're also having 4 columns, that would be 16, right, in that set.
Yeah.
And knowing that, you can stack that and get a third dimension. You can actually build a cube like that, and you can continue with the whole scheme if you want to. I don't think the game will do that, but yeah, this mathematical scheme works great, and it works as long as you have memory.
Ah, you mean
Yeah,
computer?
if the computer runs out of memory, you can't.
Ah, okay.
The computer will say, I literally can't even. To the point where if you compile a program that has too big of an address space, there are 2 things that can happen. Either the compiler tells you, hey, wait a second, that's too big, or the compiler does not complain, and you try to run it and it immediately exits because there's some fundamental memory allocation problem and just says, screw you, I'm done with this. Yeah. Right, but none of these will happen to us in this in this little program.
Okay. I didn't get the last part, but I think it's okay.
Yeah,
It's just for programmers out there.
yeah. If you're a programmer, feel free to correct me in the comments.
Okay.
And if
then
not, also
in
just-
line 4, you just subtract 4
Yeah,
and copy to the temporary tile over there.
yeah.
Then you check for negativity.
Suppose the value was 2. If you subtract 2,
It's 0.
it's minus something.
Don't
sorry, 2.
What?
No, wait. If
Wait,
I
that's
said
0.
subtract 2, right? I meant
Yeah.
subtract 4.
Okay.
So if you have 2 and subtract 4, it would be -2. And that would be negative. So you would know that you're kind of done there.
So if it's negative, you jump. If it's not, you are bumping
Yeah.
+1 to the 0 we just put in on that tile.
Yeah, it's kind of try to remove a 4, and if it was successful, then we know that it is. We count up how often the subtraction was successful, and that's kind of how often the division. So what's the division factor? The division factor, and that's how you math division factor.
Division factor. Okay, so you copy from T, the temporary tile, and then you repeat it. That's
Yeah.
the jump here.
Yeah,
Do
because
you
the
jump?
way the bump is implemented is it actually removes the thing in hand.
Ah, you jump right back here to the top, okay?
Yeah,
and then
and
you
you try to
subtract 4
subtract,
again,
yeah.
okay. Just to find out which row and which column you are in.
Yeah. I also I think there's a small bug. Can I? Because like if it's negative now, you can already jump down here. And the way it was implemented before, you would have to add 4 to it, which you don't have to do, I think. So if we check one line earlier, we can make the program smaller and run faster, I think.
So
And now
maybe-
I probably crashed it now.
Do you
Probably
remember what
doesn't.
you put out there? Or-
What would I removed?
Yeah?
Yeah,
Okay, that
sure.
should be-
Why not?
Okay, let's just run it to see how it works.
This is why in programming, like in companies, you have a thing called a repository, where like each and every check is a changes log. And if someone changes like a small line that breaks everything, you can kind of say, alright, let's go back to the previous version.
Yes.
We know that one worked, so let's go back. Okay, so yeah, I broke it. I totally broke it.
At a box.
I totally broke it.
Okay, what did we remove? Exactly.
Yeah, I can rework this. Yeah, right. So if negative, we add 4. That's. I hope that's. Yeah, it's. I might have broken it. Okay, so. Right.
Okay, let's see again.
So we just initialize the variables. That's in generally good practice.
6 is bigger than 4.
Copy to 2, right? 1.
2. This should be a negative number.
Yeah. So
So
we're
it's
done
jumping.
now. Add. Oh, that's right. That's right. And then it is in 1, 2. That's the coordinates. And that is the same number. Just works again. Excellent.
Okay.
Like a charm. Which is funny because charms don't work. So I love the expression, it works like a charm. Because you can't tell. The person who said it works like a charm, does the person believe the charms work or does the person not believe it works? Like,
It's just a saying.
yeah,
so
it's
it
just
doesn't really-
the saying usually means that it works, right?
Yes, and you're
It
happy
works like
about it, and
flawlessly,
you are
like a
wondering,
charm, like
you're
magic.
You're wondering that it works that good, that well.
Well, I
Think
wouldn't
that
go
it's
that
so-
far.
Well,
Like
a charm that
it works like a charm.
implies it. It implies like
That
a
you
charm,
don't know how
a
it
charm
works.
doesn't exist, and it works like a charm. It's like a little bit surprising,
Okay.
and you're happy about it.
Yeah, see, there were 4 steps too many, and I bet it's the add 4. If we can remove that, we would be... I want to try to remove that statement. That can't be true, right? Why do we have to add 4? It's because we subtracted 4 earlier. Okay, let's double check this. We subtract 4, and if it's negative, we know we're done. So, okay. If it's not negative, we copy it, and then we have to instead copy it beforehand. No, wait. Okay. But then we have to copy from, which does not do anything for us. It looks better now because we got rid of the absolute value. Okay, so we copy, we get the thing from the inbox. And this is the value we work with.
What are you doing?
Well, if we subtract 4 and it's negative, that means that we're done. We need to revert what we just did, so we have to add 4. That's still true. There has to be a way to do this faster. This adding 4, that's.
Do you have to add 4?
Well, but then we don't copy from T, which is exactly what I reverted the program to where it was. I need to add 4 because we're lower than 0 right now.
Yeah, okay.
So that's why we have to add 4. Copy to T, bump count, copy from T. I want to get faster with this. That's the whole thing. I think I did not break this, right? Did I change anything? I don't think so. Okay, right. So I want to go back there. We know that the values we get are less or equal.
It is not faster.
What? I changed something and now what?
We are faster than before.
What did I change though?
Wow, you have to look at the video.
Well, I will look at the video.
Yes.
We're done here. We're done. All right, that's episode, level 39. Let's go into level 40 and then also 41.
I think this took a little bit longer. Maybe we should take another video.
All right.
And do the 40
I think
and
40 and 41 are also separate videos, right? Because the last one, the final ones tend to be longer. So
yeah, could be.
yeah. So see you all in the next video. Thanks for watching.
Bye.
Bye.